Hello YouTube. In this series that I'm starting today, I want to document the progress and development I'm going through for a few of my just fun programming projects. This summer wanted to I wanted to do this summer before this current one, and I'm making this video on July 15th, 2020. Um, I wanted to do this last year, but I didn't get to finishing it. So this summer, I decided to actually get it done. So I wanted to build a game of some kind uh, in in Java, and I wanted to do it over the summer in my spare time. And this video is going to go over what I've been working on so far, and then future videos, if I decide to continue the series, will just document what I've been working on since then, um, things I've been adding to the game, and I also have a couple ideas for other games I could make in the future. I'm not sure when I'll start working on those. So, in this first video, I want to just go over what this project is. So, if I start the game, you'll see it's a procedurally generated 2D platformer. I don't know, it's not like a platformer, because there are like platforms above you, just, terrain below you. I'm not sure if that discounts it or counts it as a platformer. But you'll see there are enemies in the level, and when they collide with you, you'll see that this health number in the top left of the window goes down. And another feature of the game is that there is no set limit to the player's velocity at all. So, like, yes, there are factors that can cause it to decrease, such as the uh, colliding with blocks, as you'll see here. I hit a block and I stopped. And if I let go of a key, I should probably find a long flat stretch to show that off. But if I let go of a key, you'll see that I gradually slow down. And yeah, so the only real reasons why you would lose speed in this game would be colliding with a block or friction, which friction is only applied to the player if they let go of the uh, if they let go of the A or D keys. And this terrain here is procedurally generated. I think I already said that. So it just goes on and on forever. And behind it, we've got this background, which has just two layers to give it a bit of depth. We've got some clouds and just a simple background in front of that. I guess it looks a bit like mountains or hills. I don't know. I might change that later. I'm not sure if I like it or not. And that's just about all there is to it. It's a pretty simple game. I plan on adding a few more features to it, though, such as power-ups. You see in the top left corner, among the score and high score, is also a health value. Sorry, not health, fuel. Health is a given because you take damage from the enemies. But fuel is not. That's part of a power-up I'm thinking about adding. Or maybe I might set up multiple power-ups that all work off that same value. Maybe I'll change that to, say, power instead of fuel. I'm not sure. And my idea for the first power-up I'm going to add, it's going to be a bit of a jetpack that lets the player fly, essentially. But it does have a limit because every because as you're holding down the W key to activate it, you will use up that fuel value, which again I might change to say power or something like that. And that way you uh, and the two main reasons for adding that are first, it helps you to avoid the obstacles here. So often the terrain goes up quite steep, and since the player has to jump in order to get over obstacles, namely tiles, uh, hitting one causes them to instantly lose all their speed. And so if I want the player to, if the player has the power up, they'll be able to avoid that more easily. So the player only jumps like 1.5, maybe 2 blocks. I haven't actually measured it. I just chose an arbitrary value for how strong to make the jump. It looks like it's 1.5 tiles, and so they'll be able to more easily avoid that. But they will have to keep their power level high, and I'm not sure exactly how the power will recharge. It might be by touching the ground, um, or perhaps it will recharge whenever you're simply not using the power up. I think that might be a bit overpowered because then the player can just hold it down as much as they want and then let go of the uh, they can just let go of the W key to stop using the power up and then wait maybe just a second or two, and that'll be all they need to recharge it enough to again fly back up to the top of the screen. So I'm thinking that they'll have to come back down to the ground to recharge it. That's I think that makes the most sense balancing wise. Uh, Another power up I'm thinking about adding is perhaps speed, and if I choose to make the enemies destructible, i.e., you land on them or something like that, that you can destroy them, and in that case, perhaps landing on enemies will increase your score, but also we can have a power up kind of like the star in Super Mario Brothers that makes you invincible, so that just touching an enemy um, will instantly destroy it. That's just a few ideas. Um, yeah. So this series is just to document the things I'm working on and um, just talk about the things I'm thinking about, share the things I'm learning. If you have any questions about this project, feel free to leave them in a comment below, or if you have any suggestions, anything you'd like to share, I would like to read. I do intend to read all the comments on this video, if there are any. Um, my channel's very small right now. I don't expect it to grow uh, from this series, but yeah. So next, so now that you got an idea of what the game looks like, right now at least, next I'd like to um, perhaps give you an idea of how it works internally. If you work with game development already, you probably have an idea of how I'm doing this. It does look a bit like Minecraft. Um, Looks a bit like a mix of Minecraft and Terraria, except that it plays like Sonic a bit. Um, Another thing you might notice, if you move backwards, uh, then you'll notice that the world is missing behind you, and that's because to improve performance, I remove bits of the world that are behind the player. Perhaps at some point I will add in some reason why the world is being eaten up. perhaps the player is trying to avoid being destroyed themselves along with the world. I don't know. At this point, I really don't know. Um, I don't really have any ideas for this game story-wise. I don't know if I'll ever add anything like that. Another thing I'm just now noticing is in a previous so one of the biggest challenges for me so far is um, collisions. Not really collision detection. Detecting a collision isn't actually that hard, um, at least when your sprites are really just when your hitboxes are just rectangles and you and it's a 2D game. It's pretty easy to check to see if two rectangles are overlapping one another. It can be done in one line of code. Uh, what's more challenging though might be to interpret what you should do once you know that two objects are colliding. So perhaps that's what I'll go over next. So if I close this and the entity class, which is the superclass for enemies, players, and also the power up, which is still very early in its development. Um, the entity class handles all that collision stuff. So if you look through here, we've got just a lot of methods in here. So here's the constructor, here's all the variables, and down here we've got this method check level collisions, and it just checks to see if the entity in question is colliding with any of the tiles in the level. So for every chunk, which we're going to call chunk in the level, and then for every block, every row, for every block in the row, we're going to um, just run this math here. This is some pretty simple stuff. Essentially what we're going to do, so new x and new y represent where the player is going to move in the next tick. So that's not where they are now, it's where they will be in 1/60th of a second. And so we need to make sure that that location is safe. Make sure that it isn't in a block. So first thing we do is, so we're going to compare here, B is the block that we're checking against right now, and we're going to do this to every block in the entire level. And actually, this could probably be optimized. What I can do is perhaps only bother running it on chunks that the player or entity is currently near, or only the row that they're currently near, that sort of thing. There are always optimizations. Right now, in almost every device that I've tested this game on, it maintains a good 60 frames a second. Just about every device I've tried it with, so not really much need to optimize it for that. So I'm not going to bother right now. But yeah, so we're going to get the x of the block and then add its width. And if the new x, and by the way, new x is in the top left corner of the entity. So if it's less than that, but the um, x plus the width of the entity is greater than the x point of the block, then these two lines together, if both those conditions are met, that means that on the x axis alone, the entity and the block are definitely overlapping. And then this third line does the same thing, or this third and fourth line do the same thing for the y coordinate. That probably made not much sense, I have no script here. I'm just rambling, trying to talk about some stuff. And then here we've got some checks to make sure that the block we're comparing against isn't like air or grass or a tree, since we want the player to be able to go through all those things. But what's more challenging, I think, is this move method down here, um, which you'll see is much longer. And down here I've got the old way I interpreted collision detection. Uh, um, and you'll see I commented the whole thing out so it doesn't actually get run. So here we've got um, the way I detect if the entity in question has hit a wall and the ceiling. If they've hit a wall and a ceiling or a floor, that means that both axes are bad and would lead to the player being stuck in a block, so we shouldn't move at all. And this is just how I did it before, and that led to pretty frequent bugs. The most common one was situations where the player, you know what? Let's open MS Paint, and if I go to properties, 100 by, let's go 100. Alright, so if the player is like here, and there's a block here, and the player has pretty strong X velocity, a pretty strong Y1 too, like maybe they're falling in this direction here, then in that situation, my collision interpretation kind of got confused about where the player should end up. Like, obviously, if you take these two axes together, they'd end up here inside the block, which is bad. So we can't do both, but either one is fine. How do you choose which one? And how do you... this is just something that my initial interpretation struggled with. The new one seems to handle this much better. So if I go up here, first we check, did both axes collide with something? We've got 3 different checks. We check the x-axis, the y-axis, and we check both together, which accounts for movement on an angle. And you'll see that at the end of each of these if statements, we have a return command, except for the last one, because it's the last one, we don't need one, it's going to return anyway. And that way, if we end up in a situation where both would work, one of them, the one first, will get chosen over the other. So we see here, yeah, so here, if both collided, so if the angle collided, or actually not, so if going on an angle is fine, then we know we can move the player in both axes at once, and we can do some special stuff to apply friction, that sort of thing. And down here, this is what we do if only the y-axis is safe. We can apply the momentum on the y-axis but not the x. And the same goes for the x-axis. We just replace all the y's with x's and the x's with y's. Basically the same idea. And then the last one is for the worst case scenario where everything would lead to a collision. And one thing I kind of want to consider doing, and I think we're going to try this right now, is you'll see here, if only the y-axis is clear, we will move to the new y-coordinate, and we set the x momentum to 0. And and essentially the axe momentum stores. I don't think I'm using the correct physics terminology there, and um, I'm not sure if I got it exactly correct, but essentially what I wanted to do there was store how strongly they are moving in a certain direction, so that if a player lets go of a key, they can preserve, well, their momentum. But you see here, um, this is done once every 60 seconds. So if in the next, or sorry, not once every 60 seconds, that's once a minute, that's very slowly. We actually want once, or we actually want it 60 times a second. This is run 60 times a second for every entity. And what we want is if the if we find that in the next 60th of a second, the player will hit a block on the x-axis, we want to prevent that by just canceling out all their momentum. But perhaps, since we're not really moving them, see, we only move them on the y-axis for this tick, because we know that the x isn't safe. What if we just decreased their momentum but didn't move them on this tick, so that maybe on the next tick we find, well, we're moving them by a lower amount because their momentum was decreased. Maybe on the next tick, they can move a smaller amount that will be safe. Maybe they are, maybe they're a half block away from the next block in their path, but they're moving at like 120 blocks a second, maybe faster, and so in the next 60th of a second, they will hit that block. Um, and so we need to make sure that they, we can afford to let them move a little bit more. So I figure let's make that change. So the way you do that is instead of setting it to 0, we do x momentum times, let's go with 0.5 just to test things. And we're getting an error because that's apparently going to turn it into a double as opposed to a floating point value. So I guess I'll just cast it to a float. If I can type float. Oh, I need to cast the whole thing as a float. There we go. Yeah. So we can do that for that line, and then we can copy both of these lines down here. And let's see. If drifting. Now, drifting here, that is a Boolean value, or a yes or no, true or false value, that stores if the player is sliding. I guess I should change it to say sliding. That's more accurate. That's just what I chose at the time. That's just the word that came to mind. Whatever. I guess I was thinking of a car game, maybe. And so if we are sliding, and okay. Alright, I haven't looked at this code in particular in a very long time. So it decreases linearly until reaching 0. So if it's less than... Oh, if it's less than negative friction. Okay, so if they're moving backwards, we'll add it. But if they are between, we'll set to 0. Okay, so I shouldn't change that. That actually is correct. Okay, so then let's press Shift F10, and this should be safe. If not, I know what I changed, so I can make it work again. And the change here is that, oh, you had a bit of a lag spike there. Looks like my FPS is still 60 though, so that's odd. What we should see here is that the... Oh, actually, now that I think about it, I think the player uses a different interpretation of collision. Do they? Yes, they do. Okay, so those changes weren't applied to the player. And there's a reason for that. You'll see here that we have to move the camera um, when the player moves. So I need to... Hold up. How different is this? How different is this? This shouldn't be very different at all. So both collided. Wow, this is completely different. This is completely different collision detection. Or not collision detection, collision interpretation. So what I'm going to do is... Let's make a few changes here. So first, if we don't use one of these movement values, so if we're not going to move on the y-axis, we'll set the other one. If we're not going to move on the x-axis, we're going to set the x movement to 0. If we're not going to move on y move equals 0. And here, x move equals 0, y move equals 0. And now it should be safe to use this same collision on the player. And what we can do is, you'll see here, we've got this line that says level.camera x plus equals x move. So that means we should move the camera the same amount that the player moved. And we do that in several cases here. And for to keep things simple, I'd like to completely change how this works. So let's comment out the whole old version. And what we'll do is super.move, and then x move, or no, level dot camera x plus equals x move. That should work, because if we don't move on the x-axis, we're setting x move to 0. So that means that the camera shouldn't move when it doesn't need to. That should simplify the code a bit, give the player some more... oh, that's weird. The player is exhibiting a bit more friction in the air than is usual for them. I think that's... yeah, that doesn't seem normal. I don't know. Yeah. Yeah. So probably there was something in the entities code. So let's see. If not both collided, so both are clear. But hold up. I shouldn't... You know what? This first video is gonna be more than 30 minutes long because I don't want to stop right now. So why are we running this in both clear? And I wrote this like a week ago. This code is from like a week ago. I've been doing other stuff this week. And I wanted to show it to you in this video, but now I'm thinking there are a few things I should change about it. So we're gonna look at it just for fun. Yeah. So if both are clear, then why are we running this? Why would we consider that? So where does drifting get changed? Okay, so it's declared up here. Where does drifting get changed? Yeah, it's set here. Perhaps it's in here. Yes, so in get input, which is a method exclusive to the player class, but the enemy class has its own version called plan movement, which does basically the same thing, but of course we're not getting input from the player here, we're just planning things out. And so we set drifting to true by default, and then we set it to false if the player touches the left or right keys. Okay. So that's what drifting is really set to. Is the user currently touching that? Which would also mean... Okay, no, so drifting is still applied for the enemies. Okay. So I don't see an on... Is there an on floor in the player? Yeah, there is an on floor in the player class too. Okay. Okay, so... So why would this run in situations where we're not colliding with anything on the y-axis? And so, because of gravity, technically speaking, even if you don't end up clipping into the ground, that tick will still have had a collision with the on the y-axis, and that's what would have told it not to clip you into the ground. So that would mean that this code should never be run in both collided. That would be insane. It should really only be run here, if only the x-axis is clear. So that's pretty weird. So let's move it. Control X, Control V, and see what happens. We should say that there is much less friction when you're in the air. That's what I remember. That's how I remember it working. Also, the player should be able to let go of a key and expect, if they're moving at a fast enough speed, to end up hitting the next wall, the next block. So let's test that. Okay, we had a bit of a lag spike there. I'm really not sure what's causing the lag spikes, or if there's something I can do about it. So let's test the changes. So right now it looks to me like in almost every case I am actually hitting all the way up against the next block. So that is the way I wanted it. Very good. Yeah, there we go. So the best way to test this, though, would be to hit a wall moving at a high speed, like a very high speed. And that way we'll be able to really know if this is working. It looks like I've been hitting some of these walls at a pretty decent speed, but I could be going faster. And yeah, so yeah, if I let go, and I wait for myself to hit the next wall, I almost always end up going up right next to it. So that seems to be working. And I see no bugs in the collision, so uh, that should have substantially simplified the collision code. Oh, that's bad. And I know exactly what happened there. So the player has some special code in how they move. You'll see here. Cannot go above ceiling, so if y equals 0, cancel out the y of momentum and don't move them. If they go above the ceiling, don't do that. But if they go below the floor, we trigger a game over. So what I can do is I should be able to just copy and paste this code into the new interpretation. And that should just work. So you'll see this is a lot simpler now. And I should be able to use that for all future entities I should make here. So now let's check if I can get a game over by falling out of the world. Yes, I can. Alright, that is working correctly. So I think I'm going to end this first video here because I do want these videos to all be about 30 minutes long. So to summarize, we just looked at the game, how it works, and we got to know its collision detection, and we looked at how we can improve it. I keep saying collision detection. It's really not detecting collisions. The detecting code was just fine, really. It was the way I... Oh, hello. What happened there? Did you see that? I got stuck against a block, and the camera continued to move. That was really weird. So I guess I'm gonna stop recording now, and I'm going to immediately start recording a part 2, which I guess I'll post also today, and then see what happens. See if I can replicate the bug. All I was really doing was just moving really fast, and I hit a wall, and I guess maybe I was coming at it from above slightly. Yeah, I'm gonna have to look into this, do some testing. Alright, that's it for now. And by for now, probably for like the next hour.